Okay, so if you have your laptop open, you can close it. There's nothing there that is interesting. Thank you very much. Everything that I'm going to talk about is actually online. You can look at this later if you really want to. There's a very detailed guide for ZeroMQ, which explains everything I will talk about and much more in horrible detail. That's why I'm not going to show you slides or source code or anything computers. This is really about people and about what we're doing with our software and how it exists. And more generally, how we make open source successfully on a large scale. So how many of you here have heard about ZeroMQ, apart from the meeting? Okay, if you've used it, keep your hands up. So most of you are just exploring what this is. How many of you are actually programmers or write code? Good, fantastic. I'm also a programmer. It's what I like to do. I like to write code. I like to make things happen. And most of all, I like to write code that people actually use. And I like to make money from that. And I like to have fun doing that. That's kind of my life goal, is to make some useful things which last for a certain time, not to just go in the garbage bin, and which actually are fun to make and which pay my bills. And my first job was making video games. That was a great thing. Money came in the post and I would send cassettes. Now it's software to control massive systems like the one at CERN. ZeroMQ is used very widely. So what I'll explain today is how this came to happen, this project, where it originated, how we built it in terms of the problems that we solved. Please come and sit at the front, new people. There's seats here. Please don't hide at the back. Please? No? Ça va. On peut faire ça en français. Venez, venez. Okay. So I'll explain the kind of problems that we solved and how we solved them one by one over time. It's been many, many years. The solutions that we chose and why we chose those solutions, and this may help you also to learn from our experience in problem solving on a general scale, which is what software really is about, accumulating the knowledge of good solutions to important problems. And how this works also in the context of open source, which is what we do now as a business. We only make open source products. We used to make closed source products, but they just die very quickly, which is boring. There's nothing worse than spending a couple of years of your life making a perfect product and then see it put in the bin a few years later, which happens to most closed source developments. So let's start with the basic use case. So we're talking here about a world of computers. You all have computers in front of you, little tablets and laptops that are still open. I see that laptop is still open. And these computers are basically doing stuff, and it used to be that there was a world market for 50 mainframes. That was IBM's original business plan, right? We will sell 50 machines in the world. Now, what happens, of course, with technology is that every year, every couple of years, the price falls. I call this cost gravity. And as the price falls, the number of people buying this stuff increases, the number of units increases. And you have this exponential fall of cost down to zero and exponential rise of quantity up to infinity. So you can take any calculation of how many computers there are in a particular space, and every 2 years it will double. Okay, this is a fact. You can argue, but this is my observation of reality. And those computers have to talk to each other, otherwise they're useless. There's no point making boxes that just sit by themselves. The simplest, if I can borrow your mobile phone, the simplest, these computers just talk to one thing. They talk to the closest cell tower. They don't talk to very many computers. And their view of the world is a very simple world. These are, the ultimate thin client. But it's a bit of a shame. This is a full multi-core Android Samsung. Very nice phone, actually. They're one of our clients. They use ZeroMQ, and it runs on this phone, by the way. This is a very powerful computer. It should be doing a lot of things. It can act as a server. It can talk to many peers at once. It has a full networking stack, able to handle thousands of connections. So this is being wasted. And the reason why it's being wasted is that to make these connections work today, at least until ZeroMQ arrived, is very expensive, right? If you've written TCP protocols by hand, you know that it's very expensive. I mean, you can open a socket and you can send something on the socket. It's a simple API. And you can deal with some errors, and then you can decide to send a length and do some encoding and then make it portable, because this is all completely non-portable. You have to do special this, include that, and change with that and different error codes. And then it's all blocking. It's very slow. You have to make it asynchronous, make some selects and polls. This gets worse and worse and worse to the point where making a simple connection from A to B will take you weeks or months to make it work well. Now you want to do this 1,000 times, and you can't. And so we have this infrastructure, but we simply can't use it. And that's the kind of the situation. And the problem gets worse and worse every year. So our original clients for this technology were banks, investment banks, who aren't the best people in the world. I mean, they're a little bit corrupt. But what they do very well is try to use their technology profitably to make money by stealing from other people. But okay, they have these machines, these computers, and they're doing transactions, and they're paying people to make this stuff work, and it's only doing a few 100,000 per second, and they're frustrated. And so they came to us and said, please, Mr. Imatics, make this work faster, make it cheaper. And so we began looking at this problem of cost, and we discovered that really the problem is, first of all, is that there's no real competition in the market. You have every supplier creates their stack, and then they sell their stack, and they don't talk to each other. So if you even start using a particular product, you're stuck forever on that product. And then, of course, the supplier can raise their prices up to the ceiling, which they always do. And there's no incentive to make the quality better, except the customer complaining, which isn't a great thing. Because the more they complain, the more they will pay, in fact. So the first thing is competition. And you get that by making open protocols, essentially. So our first step in this direction was to make open protocols. And from that came something called AMQP, which was like the first really deliberate attempt to make a neutral transport protocol to connect pieces cheaply, asynchronously. I mean, HTTP is, of course, very well known, but it's completely synchronous. It's slow, it's chatty, and you can't use that for any real work. So we made AMQP, we made an implementation, brokers, clients, and we made this work, and it worked very well. And then some other large companies took hold of the protocol and made it very bad again. So at that point, we were like, no, we want this to be really open, and that means the protocols have to be really accessible to anybody and really cheap to make and change. And implementation should be very, very lightweight. And so we came to this idea that you wanted to solve a general bunch of problems, but in a very lightweight fashion, a very simple, reusable, portable fashion. And that was the kernel of the idea of ZeroMQ. So I'll go through the problems that you see as a network programmer. You have, first of all, framing. It's like, how do you represent stuff on the wire? Is it a text string? Is it a length plus a content? Is it a bunch of things followed by a blank line? Well, there's some kind of framing. And every single network transport has to invent a framing. So we built a very perfect framing. It's very simple. A length and a content, some flags. It's very good for long frames. It's very good for short frames. And that was our first protocol, was just framing, nothing else. And that's the ZeroMQ protocol version 1, it's just framing. And then, after a while, we realized that we want to send some special commands on the wire. So we had to add little special messages. And we realized that we wanted some version detection. So we added in a version header. And that was the version 2 of the protocol. It was a version header plus framing. And then, many years later, we decided we want security. And so we added in also security negotiation, which we have now. So the protocol gets, over time, progressively more sophisticated. And we learned to make it backwards compatible, so you could always plug in old boxes into new networks and they would magically work. That was part of the protocol as well. And out of this protocol, in the beginning, came this very little stack, ZeroMQ, which was focused on reading and writing these frames as fast as possible to peers in particular patterns. Now, if you look at what you do when you connect computers, if you have one client talking to one server, I call this the Facebook model. It's like, where's the internet? Well, it's Facebook. And this is how my daughter conceptualizes the internet. She has her laptop, she has her phone, and then she talks to Facebook. And that's for her the internet. And everything is there. Her friends are there, her chat is there, her messages are there, her photographs are there. Of course, that's not a very realistic representation. In reality, she also has to go to Gmail. So there's at least 2 internets in her mind. She's not yet on Twitter, so it's, it's still limited. But in reality, you want to be able to talk to many, many peers at the same time. And what emerges from this, and what we saw from the finance world, are a bunch of very central core patterns. like the DNA of messaging. And this emerged by observation. These are regular repeating facts of life almost. They're almost natural patterns. And they are, first of all, the radio broadcast model. It's like what we're doing right now. If someone comes in late to the meeting, they miss what I said before. If you fall asleep for half a minute, then you miss what I'm talking about now. And you come back, wake up again, or close your laptops, and you will catch up with what I'm saying. It's okay. It's really okay. Sorry, taking notes. Everything I'm saying is online already. So writing this down is completely wasteful. Buy my book. Okay, it's 30 euros from O'Reilly. It's called ZeroMQ by Pieter Hintjens. And it's a really, really good book. I'm really proud of that book. Don't take notes, okay? Take photographs if you really want to, but don't take notes. You're not even typing, I'm sorry. Okay, I'll stop heckling you. Okay, so these natural patterns emerge, and the first pattern is this radio broadcast pattern where there is a publisher, we call this pub sub, and the publisher just blasts out information with no real concern of reliability or security. It's very cheap, and although we're not used to this in IT, where we think in terms of confirmations and acknowledgements and did I get it, in the real world this happens a lot. This is like the most common communications pattern, is simple, raw, stupid pub sub. It's how TV works, radio works, it's how real life works. We subscribe our eyes to reality. This is how the world actually works. So we actually built this into ZeroMQ as a kind of native pattern, and it turned out to be incredibly useful. The next pattern is the old-fashioned pattern of request-reply. It's like, what's your name, sir? Sorry? Sorry? Mitko. So that's a request reply with three requests and 2.5 replies. And that's standard pattern. You need to have a precise answer. You repeat the question until you get the answer. Eventually you give up or you don't give up. Request reply. The next pattern we had came a little bit differently. It came from workload distribution. So we have, for example, you know The Hobbit and the Lord of the Rings, right? These very boring films where people do stupid things, I don't know. But it's all digital, it's all animated, and they have these huge render farms, Weta Digital. And so they use ZeroMQ for this, and what they do is they have these servers producing their frames as kind of little vector packages. They're quite small, little PowerPoints, if you like. And then they're sent off to this whole bunch of workers which have GPUs, and a worker is a PC, it's a board with 4 GPUs, and they take frames and they calculate for a minute, and then they produce these very high resolution frames that nobody watches. Sorry, everyone likes those movies. So this pattern is not a natural pattern in human activity, but it's very common in data processing, where you send work, gets farmed out, and the results get brought back in again. We call this a pipeline. So we had these 3 patterns, and after a while we realized that, you know, network programmers like sockets. We know about sockets. It's a kind of standard API concept. So we wrapped these patterns up and made them look like sockets. And that was ZeroMQ version 2. That was what hit the market. People loved that. And we realized at that point that the biggest problem in communications, the biggest reason why it was expensive, was that it was too complex. And so if you look at ZeroMQ, what you will appreciate as a developer is how simple it is. And that simplicity was the result of many, many years of trying to boil down the essential problems and find the simplest possible solution for those. So the API that gives you access to a pub/sub socket or a request-reply socket or a push-pull socket, those APIs are simple, and they give you huge power out of the box, because we know in most cases how pub/sub should work, and we can implement that inside the socket. And then the ZeroMQ sockets are like servers. They are fully capable data processing machines, network machines, multi-threaded. But the socket API is what you use to talk to them. You say send message, receive message, set option, very simple. And this transformed the way we wrote network programs. And before that, it was always special APIs talking to special middleware. It was doing it by hand. It was downloading some weird thing. People still here using JMS, which has a very standard API, but it's a very weird and complex API, which is very far away from these natural patterns. And so the ZeroMQ API is what made the product successful. People love that API. And we first made this API in C. Although the library is C++, the API is exported as a C API. And then people began using it and wrapping the C API in other languages. So we very quickly got a C# binding, C++ binding, ironically, Python binding, PHP bindings. And then it just exploded. And today there are 40, 50 different bindings. The only language I know that is not supported is one called Spec, which means bacon in Dutch. Which, I don't know. There's actually another one called Chicken, which is supported, ironically. And it takes about 1 or 2 days to make a particular language work with ZeroMQ, because most languages can include native code. The building may be a little bit tricky sometimes, that's about it, and then it works really simply. And you get the same API in your language, so you get the same sockets and receive and send and options in whatever language you're using. And so ZeroMQ grew from this little library to a library plus a whole collection of bindings around it. And above those bindings, communities of people building products. So for example, above the Python binding, there's a thing called IPython, which is a platform for maths, distributed maths computing, interactive Python, which uses ZeroMQ for its distribution. And they love that. It's so nice and so scalable and so easy to use. So you then saw a whole generation of new products existing only because we brought the price down so low. And again, it's always about cost. There's nothing here which was radically new. It's just TCP or InProc or multicast. But it's being able to take those problems and solve them for much less than before. It used to cost, I don't know, let's say $100,000 to connect computer A to computer B. And today it costs $1. That means you can connect 100,000 computers for the same price. And now suddenly it becomes reasonable and logical to see all those computers in a particular space talking to each other and all doing pub/sub and request reply and pipeline and other patterns cheaply, economically. And now you see why it's possible to use ZeroMQ in CERN to control all of the instruments and devices. Because before it would cost 10 million, and today it costs, I don't know, 1 million, to give a figure. And for the same budget, you can now do a lot more. Furthermore, you can increase the size of the networks without paying too much. Before, it was prohibitively expensive to make larger and larger networks. And that's the software story. So that's the story of how the software came to exist. We started doing messaging for industrial control in '91. It was my first project. And the first open source for that was in '91. And those were state machine compilers to produce protocol engines. In 2013 is, you're calculating how many years that is. It's a long number of years. Open source, open protocols, and then to open communities. And so what I'll talk about now is how we use the ZeroMQ community and how we work with that community and in that community to build the software, which is the part which is relevant to almost any software project. So I've been making communities for quite a long time. I tried to make them around my software in '91 when I first started, and it failed. I tried again, and it's been failing ever since. I mean, I'm very good at failure. It's my thing I'm best at is not succeeding. And then about 2005, I got involved in some anti-patent organizations in Europe, FFII, which is a German organization. And there we had this problem really aggressively, is you must make this community work. There was no choice. It was no longer about a personal project. It was about thousands of people working together. And we had no choice except to make these groups work. So we were really learning very, very quickly how to build communities to solve particular problems and how to make it work for the people involved. And they were all volunteers. It was very, very brutal, volunteer work. There's no luxury for any kind of mistake. If you get it wrong, people actually have mental breakdowns. It's really very, very aggressive. And we learned a number of tricks and techniques about building groups of people that could work together in a happy way. And then when I went to work in Poland for this company, Wikidot, which I was a part owner in, I also built the community around that platform and helped lots of people to work together to write documentation and write templates and get involved in making this big project work on a very large scale. It has 1 million users and it has 2 or 3 core developers. And that's a wiki platform. And all of those 1 million users are being supported by a community of other people who aren't actually being paid, who are working together on that. So we took these techniques and used them as the basis for ZeroMQ from the very beginning. It was a very deliberate construction. So the first thing is it's open source, it's free software, and there's a license choice. And you'll hear this discussion of what license do I use? Do I use BSD? Do I use MIT? Do I use GPL, GPL2, GPL3, whatever? So understand something about communities. Now, no one works in a community just because they want to. It can be fun, but everyone wakes up in the morning and takes action for economic reasons. You're all here for an economic reason. You all hope to get something out of this discussion. It's not just, you didn't just wander randomly down the hall and sit down. And nobody makes a patch or makes a contribution because they just feel like it. It's kind of one of these myths of open source that these volunteers are just like idealistic contributors. And people make patches because they need that particular feature to work for their own work. So contributors are investing in the project. They're investors. And the license defines the economics of that investment. And it's actually very simple. If you have an MIT license or a BSD license in a project and person A invests, then person B can take that investment and steal it. It's actually that simple. So your investment can be taken and used in proprietary code and actually used in competing products, very simply, against you, which in some cases is fine. If I'm a university and I have absolutely no reason to want to build a community, all I want to do is dump my code out into the market, I can use that kind of license, and my code will get used by everybody. But if I'm a small company or an organization where I want to build community, and I allow people to steal from the project, the community will die and suffer. It will be small. It may exist, but it will never be very active. So the magic about the GPL contract is how it forces every participant to play by the same rules. It's reciprocity, the guarantee of remixing. If person A makes a patch and person B takes that patch and makes an improvement, then person A can always take person B's improvement back. So as an investor, you have much more guarantee that your investment will have a long-term value. And the result is that GPL communities will grow more aggressively and will thrive. And once you understand that, the choice is obvious. You go for GPL, GPL version 3. And then there's some variants, and we chose LGPL version 3 with a static link exception, which basically means you can use this library in any project, because we don't want to discriminate against commercial projects. It's just that we want the patches to come back. And that particular combination of license guarantees that we'll get back patches. But anyone can use the library in any project, which is the perfect balance. That's the first thing. And the people who tell me, no, this license is too idealistic, they're just naive. They just haven't understood the economics of what's going on. So then the second thing is the contribution process and the platform. It's how do you contribute? What's the roadmap? We've had this question many times. Who decides what's in the next version of ZeroMQ? You know, is Pieter there with his megaphone saying, no guys, we must do this? Am I cheerleading and pushing people to make stuff? Well, I do this sometimes, but generally I don't do that, and for a few reasons. We discovered, by trial and error, as always, it's always about making mistakes and seeing what goes wrong, that smart people make big mistakes. And the smarter you are, the more you make big mistakes. And the fact that you can argue eloquently why you're doing something is usually a bad sign. And I'm reasonably smart. I make really huge mistakes, and I know that. I've seen myself make amazingly good mistakes and justify them through argumentation, detailed argumentation, and afterwards I realized, oh my God, what did you do? Why did you do that? Well, because you had a bunch of assumptions that you didn't realize that they were wrong. And nobody challenged those assumptions. And as you began investing in your answer, you threw away any bad data. And you know, all scientists do this. We try to prove a theory rather than criticizing the theory. And so a smart scientist always challenges his own assumptions and asks others to challenge them, and does not trust his own opinion at all. You can trust your own experience, and definitely know when you've learned a lesson, but never trust your own opinion about where to go. because you'll get it wrong enough of the time that that's a problem. However, other people's opinions, fantastic. There's also I would say, an emerging social science called the wisdom of crowds, which you may have read about, which is this notion that groups of people, even not really experts, can arrive at much better judgments much more quickly than individual experts. And experts who have the same vision on things will make big mistakes together and keep reassuring each other, this is a great mistake to make. Whereas having some layman involved in the discussion, they will challenge the assumptions and ask, why are you doing that? And then the experts are like, oh, that's a good thing. Actually, you're right, let's not do that. So when you come to building a community around your open source, the thing is to make this community diverse and big, even if it involves many non-experts, especially, in fact. And what we saw in practice in ZeroMQ was we had a few guys who were really, really smart and dedicated and hardworking, and they made the biggest mistakes. And the typical syndrome was they would make new versions of the software, and they would break the APIs, and they would break the protocols completely randomly, completely confidently, and publish a new version of the software. They would push a new version. Here's version 3. Here's version 3.1. Here's version 4. And they wouldn't interoperate. And there would be big assumptions about the requirements which were wrong, because they weren't actually using the software. And the community was struggling to keep up, having a really hard time to understand why we had all these versions, what was the value of this, and why they had to keep migrating expensively and painfully to new things which were changing for no apparent reason. And they were right, the change was not justified. And so at a certain point, I basically arranged it so these smart guys had to leave. I realized that just making code wasn't valuable, just making changes wasn't valuable. What we had to do, in fact, was to respect the contracts with our users. And the contracts were, here's an API, the API will not break. We may extend the API over time, we won't break this API. If there's a feature that we want to change, we will leave the old name, leave the old functionality, make a new feature, experimentally, then when it works, we will mark the old one as deprecated, and eventually legacy, and eventually remove it after multiple releases. And so there's this migration path, smooth, without pain, with every opportunity to make mistakes. If the new features are badly designed, they never go to stable. No one ever uses them. And so contract-based development. Contracts at the API, contracts at the protocol level. The same problem at the protocol level. This also made a very big difference. And having the contracts that defined how you could modify the contracts. This is getting rather meta here. But what are the rules that let you change an API? Before it was, change an API, you change the version number. Makes sense, right? I have version 2 and I have version 3 and they're different. Actually, it's wrong. Version 2 should talk to version 3. Version 3 should talk to version 2. So the version number shouldn't reflect API changes, it should reflect the maturity or the power of the product, but not the API. So we began to accumulate these rules on how you can change the software. You may not break the API. You may extend the API like this and like that. You may not break the protocols. You may extend them like this and like that. And this is how you do it. Then we also discovered that, and again it's obvious, but it takes time to realize this, that by reducing the size of changes that people made, we could make it stable much faster. So before that, the pattern was, smart genius would work by himself or with a friend for 1 month and produce this huge bunch of changes, 2,000 lines of code, which I consider a lot of changes across the whole project, and push this and say, here we are, new version. Then it would take about 6 months for people to go through this and test this and find all the bugs and fix all the bugs. And it would take a long time. And that was our stabilization process. And that's where we had an alpha release and a beta release and a release candidate 1, and release candidate 2, and then a stable, and then a patch on the stable. And this was going on endlessly. And then this genius would come with another 5,000 lines of code. And we'd all groan and be like, okay, what did he break now? Why did he do this? And I like random geniuses, but when they do this kind of thing, it was really getting really annoying after a few years. So we realized that by having, first of all, less aggressively smart people and tighter rules about how much change you could make, but also smaller changes, a few lines, a few dozen lines, maybe a few hundred lines, but that seems extreme. As a commit, you could test those patches, you could validate them, you could deliver them, you could use them within a very short time frame. So we had this concept called change latency, which is the time it takes from you make a change to you confirm the change is actually good, or you take it out. And get this down from months to a few hours is magical, right? If you have people actually using a new patch within a few hours, at least testing it, at least using it in confirming it in products that it works to some extent, or hasn't broken anything, which is the minimum, that's very, very good. And so we switched from this process where there were large versions that got more and more stable, progressively more stable, to this process where there is just really one version, the master version, which is almost always perfect. And it was quite surprising when this emerged as a situation, because we have a lot of contributions. We have, in the last 18 months since we made this new process, I counted about 100 contributors and several hundred patches in 18 months. And there's a lot of different projects that are involved here, and the whole thing has held together very, very well. There's been no trauma of any kind. We also use GitHub, and we use GitHub pull requests. So you never commit to the repository. You only make a pull request, and someone else always merges your pull request. This little ping pong between two people has a very significant effect on how people perceive their work. And you'll know this. If you're committing to a repository and pushing work and committing it, you're essentially working by yourself. And even if there's someone watching that, you're still having no acknowledgement. And this is one of those things where you want a request-reply scenario. You want some acknowledgement, even if it's just a sure, 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 sure. It's better than silence. And so our model is you fork the repository, you make a change, you commit the change, you test it, you push that, you make a pull request, and then someone gets an email, and someone, if they want to check it, they can check it. And there's a bunch of maintainers in every single project who get these emails. And it's up to them how much they check the pull requests. They look at them, and then they merge them, or they argue. I don't like this, you've made a mistake here and there. My tendency is just always to merge everything. I just always press the merge button. Even if it's a completely horrible pull request, I'll merge it. My reason for that is that I would rather that people engage in discussion, even if they're slightly upset by a change, than that the discussion is stopped and muted. And it's a theory that the people are much more important than the code. Community before code. The community will build good code, but good code will not necessarily survive by itself. So I would rather a troll comes in and makes a terrible patch, and the patch breaks everything, and then people argue and get very upset and come back and undo that patch, than that the patch is refused in the beginning. And this will remind you of Wikipedia. It's exactly the same principle. And Wikipedia has been criticized forever since it was started because it's open to trolls and vandalism. It will never work because anyone can edit anything on Wikipedia. So obviously you can destroy any content. But in fact, that's the secret of Wikipedia's success, is that when you make a page on some really esoteric subject and some idiot comes in and hacks it and makes a mess, you get really offended. This is terrible. And you come back and you fix that error. And then that page now is yours 10 times as much. So this little challenge response deepens the emotional bonds that contributors have with their work, makes them tied in, makes them own this much more. If no one even bothers to deface your page, it's irrelevant. So trolls are actually really useful for community building, ironically. And that was one of my strategies, was to remove barriers and to say anyone can contribute anything. And then we came to this theory of change, which I'll now explain, how we decide what goes into the product. Okay, so I've thrown you a lot of strange theories of software development. I'll give you now the very strangest one, is that we don't know what we're going to make until we start making it. Now, technically, we don't know what problems we have to solve until we get very close to the problems. Now, if we're solving the same problem 2 or 3 times, okay, we know that. If we're controlling a magnet, we know we're controlling a magnet. That's okay. But in many software projects, we actually don't know what we have to do until we get very, very close to the problem. and I compare this with driving through an unknown landscape, and I'm looking for the turn in the road, I really can't see it till I get there. And there's no Google Maps, and there's no GPS. There's just my eyes, my navigation, and me coming close to problems. And I may have theories about where the road is. I may have an opinion of the road should be straight. And it may be straight, often. But when it curves, and I really don't want to fall off the edge. So the smaller the steps I take, and the more iteratively I work, the more accurately I can map the real problem. If I take big steps, I'm likely to fall off the road quite regularly. And this is where most design mistakes come from. It's not because the person making it was stupid. It's because they were inaccurately guessing where the problem was. Problems can be seen as a landscape, where you're trying to climb up this landscape to the optimal solution. The landscape is very, very large, and the landscape is always changing over time. The hills disappear, and valleys arrive, and new mountains arrive. This is why old solutions become technical debt after a few years, because this problem gone away, and now the solution is useless. It's not enough to find the best solutions. It's also important to go and clean up old solutions and recheck your assumptions about problems. So when you have this very large landscape, a very infinite landscape of problems that are interesting to solve, how do you know where to start working? And here we have the reason why individual inventors and individual minds fail at making really good software, is because you cannot, as an individual, navigate this problem landscape. You're stuck in one place by definition. What you want is a big community of people, as big as possible, all with the kind of an agreement of the general landscape to look at, which in our case is messaging and connectivity. It could be anything. And then all exploring by themselves different parts of the landscape. And then making it very, very easy for them to share their knowledge, which is what our repository is all about. Our GitHub repository is all about sharing the knowledge of, hey guys, I found this problem, here's a great solution. Now you can always argue solutions, but if you get a good problem, that's fantastic. And so we see this in action in ZeroMQ. We see this in action, people coming with completely unexpected answers to problems that we'd all not realized were there, but were really, really important. I'll give you a few examples. So last year in August, so we have this core library, and it's in C++, and it's very fast, and it's highly optimized, and it's a result of decades of sweat and labor. And it's this incredibly complicated, nasty library. Really, it's nasty. I hate C++. Who made this language? Sorry, I'm just trolling my friends here. And on top of that, these bindings. One of those bindings is Java. And so the Java binding has to compile the C++ library as a JNI native thing. And it's a fairly nasty, fragile, error-prone pain. And you can do it if you're good at this, but this is the one thing that Java programmers using ZeroMQ always hate. They really hate this. And the consequence of that hate is that the Java binding was always really poor. It was never well documented, it was never well invested, and the people using it they always hated ZeroMQ because of this building process. Okay, so last year in August, this random guy pops up of nowhere and says, hey guys, I've ported C++ library to Java. And everyone's like, what the heck? Why would you do that? And at that point, the core developers are shaking their heads saying, this is insane, this makes no sense. Because for them, this was never a problem, and it has been obviously a lot of work. You can't port, I don't know, 20 or 30,000 lines of very complicated C++ to Java just overnight. It was someone's labor of love for months and months. And I was in Korea at the time, so I called this guy up and I say, hey, let's meet for tea or beer, whatever. And this is a great guy, and we worked together for months in Korea, Dongmin. And his speciality was taking C or C++ and rewriting it in Java. And he did this for the whole core stack. It worked almost perfectly. There was like 1 or 2 bugs, no more. He asked for no help from anybody. And so I very quickly encouraged him to make this an official ZeroMQ project. We brought it into the community. We made it properly licensed. We fixed the contribution policy. We brought it into our contribution process. And suddenly he got all kinds of contributors working on this. And this has become the dominant stack for Java developers now. They don't use the JNI. I mean, some people do, but generally most coming to it from scratch will take the ZeroMQ stack because it's much simpler. It's just as fast. And as soon as this native Java stack appeared, other people began investing in the JNI binding and making it richer. And the two cross-pollinated, and then they both adopted the same high-level API and became basically clones of each other. So this kickstarted the whole Java ecosystem back into life, which was basically dead before that, because one guy did something insane. He solved a really, really big problem that nobody was aware of or willing to admit. And if you had asked the core ZeroMQ developers at that time, what is your major problem, they would never have dared to say this, because there was no possible solution. No one was going to spend those 3 or 4 months of their free time to make this port or maintain it afterwards. So these problems are invisible because we don't even dare look at them. But for someone else, in a different part of the landscape, they're trivial. Like, yeah, that's just a couple of months of work. Hey, I do this all the time for fun. So when you get a diverse community, you suddenly get very, very different opinions of the cost and value of problems and solutions. Or something quite different, like we have this one socket type called a router socket type, which is one socket type that lets us talk to different peers kind of explicitly. And someone, for bizarre reasons, has hacked this, actually a few people, has hacked this socket type to talk native TCP. So now you have this communications library with all this weird stuff on top, which can actually act just like native TCP sockets. It can read and write streams and little fragments of data. So now we can write HTTP servers in ZeroMQ and HTTP clients in ZeroMQ. Of course, it's an insane thing to want to do because we want to replace TCP. We want to just make our own protocols. But in a world where you have to still talk to TCP services, this is fantastic, and it cost almost nothing. It was literally like a 4-line patch, like so simple to do. And suddenly you get multi-threaded, asynchronous servers and clients, the whole power of ZeroMQ on top of real raw TCP sockets. And again, it's a completely insane thing to do. And when it came out, all the core developers are like, what is this stuff? This is horrible. It's a hack. It's nasty. It doesn't fit into our vision of how things should be. But in terms of the real world and the real problems, it's absolutely fantastic. And all it really takes is some packaging. So I've made a new socket type, which I'll push today, I hope, called the stream socket type. And a stream socket type is a TCP socket with all of the power, without any funny socket options. This is how ZeroMQ will survive the next 20, 30, 50 years. It's not going to survive because it had a fantastic, brilliant original design. Because its fantastic original design will become wrong, and completely wrong within a certain period of time. It's predictable. The whole focus of ZeroMQ on performance will become irrelevant. The socket API will become irrelevant. The C++ core will become a problem over time. You can see this. This is very predictable. And the only reason this library will survive the next, I predict, 30, 40, 50 years, without any problem at all, is it will become a community, a real community that will build and keep building new versions of whatever they need, and new features and new answers to problems which emerge over time. It's that simple. So when you look at open source, don't think of software. In fact, when you look at software, don't think of software. When you look at what you're making as programmers, the lines of code you're writing is not important. The code you write is not important. It's a temporary implementation. It's like climbing a mountain, you hammer some pegs into the wall. Those pegs aren't important. They're only how you get to the top of the mountain. The language you use isn't important. What's important is your APIs, your protocols, your contracts, and your process. And around that process, how you bring people together to working on the problem space. That's it. And if you can define a really, really good problem and a little implementation, a tiny implementation, and a good process, you can try to build community around that cheaply. And then you can go somewhere with that over time. That's how I see software. It took me a long time to get there. Thank you very much for your attention. We now have time for questions. Oh, you all have microphones. You can just press the button, I believe, and it should work.
Do you want to handle the questions yourself, or do you need help?
No, anyone just press the button.
But to follow some order, okay.
See if this works, Can we do a test, maybe?
Yeah, it should work, of course.
Should work. Okay.
Anybody wants to start testing the system?
Sir.
So this idea of crowd wisdom and so on is very interesting, and it's also floated around in other sciences. So have you seen other open source projects that benefited significantly from this kind of approach?
Yes, of course. I don't know if they've. So the question was whether we've seen the science of community building applied more widely, right? As far as I know, we're the first project to try to document this as a science. Though I've definitely seen projects achieve this, and it might have been deliberate. I mean, Wikipedia is a very good example. Wikipedia is absolutely built on the principles of collective wisdom. That's a fundamental thing that has been slightly hidden over time because it looked a little bit politically embarrassing, but it's a really fundamental principle. In open source projects, you see this, I think, more by, possibly by luck than by deliberate design, possibly by natural selection. In other words, you have a huge number of open source projects, there will be a huge diversity of strategies, and the ones that work will survive, the ones that don't will die. But I never saw anyone try to replicate this as a recipe, which I've been doing for about 10 years now, writing this down. I used to call it wiki-turfing, and then social architecture, and it's now, there's a contract which you can find. It's in my book, and it's why it exists, and every single rule, why it's there, and what it does. I think this will become an accepted way of doing software in general. I think the benefits of this, I would say social technology, are so powerful, being able to organize people around problems rather than I am the boss, you do what I tell you. It's so powerful, and it's so effective in terms of building big systems cheaply and that can last a long time, is that the competitive advantages are very strong. And anyone building software the other way will eventually die. And any company organizing the old way will eventually die. And if you look at companies today which are hyper successful, they're using this kind of strategy internally, not even for software, just for management. Companies like Amazon, this is how they organize internally, is they let their people discover problems and iterate solutions around that, and management provides support to that process, doesn't direct the process. And the grand assumption is that we don't know the real problems in advance. We simply don't know them, and they disappear. They emerge and disappear. And we bring our users into that discovery process. We make our users contributors, co-owners of the solutions. And I think that is an emerging science of management in general, open source in specific, other knowledge areas also. And when you speak of open source, people start to say, let's make open source cooking, or let's make open source music, let's make open source photography, I don't know, whatever. It's not really about the license, it's about how the community organizes around the problems, I think. So what time is it, by the way? How long do we have left? Oh, we have another half an hour. Good. Gentlemen, press the...
Yeah, how do you find an equilibrium between the API contract and all the patches that are sent by random people and that you say you accept rather than refuse?
So this is a very good question. It's like, how do I encourage people to document their patches, belong to the API? How do I get the API to be stable? So first of all, the API may not be broken. A patch may not break an API, with a little bit of exceptions. If the API was still considered experimental, you can break it. So there's a cost to change. If the cost is 0, you can still change. And we know, because we go through a certain level of, we do have releases which are considered stable releases, and that's part of the contract. If the API goes into a stable release, then you can't touch it. It's holy, it's holy. If it's still experimental, if it's reasonably new, if it's obviously still being learned, you can still change that. So we will change new APIs quite a lot until they become good, because you can't get a good design right away. And then we leave them for a while, and now if they've gone into any release, if we want to change them, we have to deprecate them, but they still be supported. So new stuff comes. Now the new stuff, of course, then has to try to get used. So if I make a new feature and I want my feature to survive change, So now I'm a contributor. I made this new socket type, and I want to use it in my applications. I don't want you to come and break my socket type. What guarantees do I have? Well, the only guarantee I have is that people are using it. If no one is using it, it will always be experimental, it will be considered rubbish. How do I get people to use it? Well, I document it. I make a test case. And I get the test case in the source tree. And now when there's a build, it will run my test case. If you break my socket type, test case will fail. Aha, your patch is now broken. So the economic incentive is on the contributor to document and make a test case for their changes. Otherwise, the changes never get status. And essentially, if I have no test case, then you can legally break my API. And some people do that. They make changes and there's no test case, and those changes eventually get taken away. Or they get put into test cases and stabilized. So it's really self-regulating. It really self-regulates. Stuff which is important gets importance. Stuff which is badly done remains irrelevant. If you make a really big effort, you can take bad stuff and make it look stable. But eventually someone will interfere, because remember, we accept all patches. And bad stuff will annoy people. So you can also undo someone's change with a pull request really quickly, right? You have a certain window, and I do this regularly. People make changes, I merge them, I look at them for a few weeks, and then I make a pull request which takes them away. And then someone else merges that, and it goes away. And that's fine. And maybe someone's annoyed. I don't really care. I mean, it's not really about making everyone happy. It's about building accurate software, right? Does that answer your question?
Besides from the developer community, how do you encourage users to give you feedback and not silently go away if they don't like anything?
That's a good question. I mean, that's really in the sales and marketing of any project, is to get people to engage. So the lesson we've learned is you have to make it very, very simple to get started. It has to be compelling at the first experience must be compelling. Then you can get progressively more and more and more complicated. If you show people the complexity in the beginning, then you've lost them. Now, we lose many people. I mean, we don't try for 100% success. In fact, the marketing of the community changes over time depending who we're talking to. So you don't just have a group of users. You have a very specific profiles of different kinds of people. Now, very specifically, when the project is young and new, nobody will use it in industrial control. So don't even sell to them, there's no point. Nobody will use it in anything where there's money involved, so don't sell it to them, there's no point. People will use it, A, to write about, because their job is to be, they're journalists, or they're bloggers, or they're just, you know, these guys that love new stuff and are very good at communicating, so they want new stuff. So the very first thing is just a hook for those people that like to find new stuff. And it can be completely empty. It can just be, we are launching this project. Sufficient. And guys will say, wow, that's fantastic, I want to blog about that. And this happens. This is technology bloggers will write about new stuff. Of course, that only lasts for a few weeks or months, and then it gets boring. So then the next step is something that does some real work and gives some real value. But it's for people who are willing to take huge amounts of risk to use it. They don't really care about documentation. They don't care about pretty websites. What they want is a really good solution to a particular problem. And this was the first generation of ZeroMQ users, were people who were willing to put up with a lot of raw technology to get access to what was a very fast engine. And if you look at the first ZeroMQ users, that's them. They're people like Zed Shaw, who built it into a web server called Mongrel 2. And his job is to build frameworks for other people. He's very smart, he loves new stuff, he takes huge amounts of risk. So we sell to them first of all, and then those people build up community further around them. And then the product gets a little bit more mature, there's more examples, there's more documentation, there's more binding, and it goes to early adopters. And early adopters are people who are using the product in real applications, there's money involved, but they're still very good at managing risk. And they will never ask you the question, who else is using this? for example. It will not happen. They will only ask the question is, how much is this going to cost me? They will not ask for support. They may say, how do I submit this patch? They will not say, can you fix the issue for me? They won't do that. They'll say, how do I send you this patch? And you know they've downloaded the source code, they've read it, they've looked at it, they've figured it out, and they've made a change for you. So they're your first wave of contributors. They will actually contribute real stuff because they're using it in real projects. That's your early adopters. And that lasts for another year, 2 years. Then you come to the mass market, and CERN is mass market, because the question that CERN asks is, who else is using this? And I'm switching from Corba to ZeroMQ. I'm switching from JMS to ZeroMQ. I'm switching from TCP to ZeroMQ. So it's a migration. CERN does not want to take any risk. Taking risk would be a very bad idea when you're talking about high energy beams. So now the message becomes one of stability, becomes one of maturity and reliability. So as you go through time, your project has to shift its marketing to be able to attract different kinds of people. There's no single move there, because if you lose your pioneers, then you eventually just stagnate. So you have to have this ability to project multiple messages at once over time. You have now stability plus new stuff. It's sexy, but it's also reliable. And if your project is good, you get good at this. You begin to learn how to communicate different things, different people. Right? Does that answer your question? Okay.
Yeah, you said before that you were expecting this model that you were explaining to actually spread a little bit. And you also mentioned that we were motivated by money.
Sorry, can you speak louder? I can't hear you very well, sorry.
That you said at the beginning that
yes.
You were expecting this model to spread
yes.
on other teams that are doing software. And you also said that we are all motivated by money. So I wanted to ask you actually, how do you get ZeroMQ to pay your bills? And
okay.
How do you guarantee, if you have a very good community, that no one else will get the project
right.
and do it themselves?
So, making money from open source. If you look at a company like MySQL, what they did when they looked for investment, so in the beginning, they took their business plan to VCs, and their argument was, look, the database market, which is essentially Oracle and IBM and some Microsoft, is worth $5 billion a year. Now, we will destroy this market. We will kill this market. We will ruin it. And we will create a market that is worth $500 million a year. That's our business plan. Okay? And they got funding on that basis. VCs were like, that's fantastic. I like that argument. It makes great sense. And effectively, in the end, Oracle bought MySQL for something like that. So this is the first thing with open source, is it's not about being nice and pleasant and ideological and, ooh, I want to save the world. It's not about that. Open source is about identifying competing products and killing them. And taking their customers and watching 90% of those customers disappear and getting 10% to stay with you, if you're lucky. Or 1%. It doesn't really matter. No one needs $5 billion a year. That's a lot of money. So this is the first thing, is can you successfully attack very, very large, very powerful, very well-entrenched businesses selling messaging to big companies? Can you do that? And the answer is yes, you can do that. If you build a powerful community who are aggressively thinking about the right problems to solve, the product that you produce will be so compelling, people will be running to use it. And they will stop using whatever the big companies are selling. This is happening. This happened for years. Of those people that are then running to leave the big companies, a certain number will come and ask you for help. And as I explained with the different market segments that use technology, the early adopters and the pioneers will not ask for help. They're your contributors, essentially. They're your business partners. They're your stakeholders. The ones that want help are basically the late adopters and the stragglers. The ones that cannot even think of risk, it makes them suffer and sweat, and they want no risk at all. They want the guarantee it'll all work. And you're like, well, it's been working for years. No, I want a guarantee on paper. You're like, how much are you going to pay for that? Oh, I'll pay you, it's good. And they're still paying millions to some other supplier for something which is really, really nasty. So for that, it's a fantastic deal for both sides, right? That's how MySQL made their money, by taking out dissatisfied Oracle customers, not by selling to millions of new web developers, because those guys paid nothing. But they created the market, and they never used Oracle. And in the end, MySQL became a very valuable box for Oracle to buy. Now, that also killed MySQL. So I have a slightly different vision. I don't really care about money so much, because I'm a nice guy. So I have enough to live on, and it makes a good business. My goal is to see this technology last for a very long time, and also to make the basis for other products. So we designed the copyright process, the copyright contribution process in ZeroMQ to make it impossible to buy and kill. Not just difficult or expensive, but literally impossible. Now, what MySQL did, if you submitted them a patch, is they would ask you to transfer copyright to them. And they would create this one single ownership. And then they could sell commercial licenses on the side, and they could sell the whole copyright. Now, of course, you can fork it. You can make a fork, and there's a fork called MariaDB, which is a fork of MySQL. However, all of the MySQL developers are now working for Oracle on a closed source or a differently licensed version of MySQL. So that whole branch of activity is now privatized and closed. Right? So the cost to the community to save the product is extremely high, and probably too high. It's probably an unbearably high cost, which means Oracle's business plan will survive. They will actually make money from that, because it's still cheaper to buy that new work from Oracle than to make your own work. Now with ZeroMQ, we switched to a model where every contributor keeps their copyrights. That's it. It's very, very simple. It made it simpler to contribute, but it also made it a distributed shareholding of the software. There's no single owner. And if you come to me and say, Peter, we want to pay you $1 million for a commercial license, I say, adios amigos, we don't do that. I'll pay you $5 billion. I say, doesn't work, we don't do that, I'm sorry. You can't dual license the product. It only has one license, and that's LGPL, version 3, with a static link exception. Now, of course, you can take the software and you can make a closed source version of the software, but actually you can't. You can hire all developers, but they still can't work on a closed source version of the software. If you pay me to work on ZeroMQ, everything I make must be open source, it must be GPL. It doesn't matter how much you pay me. So the software can never get closed off, and the community can always get the latest version, no matter who is working on it. It's always available. So the cost is always lower to keep using ZeroMQ than to pay someone for it. That's why it'll last for a long time also, I believe. Right. And these are these are simple answers to problems that we've developed over time, which we try to encourage other free software projects to use also. And making money, honestly, consultants, support, add-on products, selling books, selling t-shirts, it's not that difficult. People do have money, they like spending money. And it's really not that difficult. You just need a salesman and a smile and the willingness to, to send invoices. It's surprisingly easy if you like that kind of thing. I'd rather write a book than an invoice, to be honest. But, okay. One more question. Sorry.
I have a question if there is like so-called serious client which having a mission-critical system, like power plant, nuclear power plant, and he wants to assure the 24/7 operation and response time,
right?
And wants his back to be covered. And apart from enthusiasm and community, what can you suggest as the business model? I mean,
first of all, with technology, there's never a guarantee of functionality. I mean, you buy TCP. Who supports TCP? Well, no one supports TCP. You just have a certain body of evidence that shows it will work with a certain guarantee of service. The guarantee is still on your shoulders as a user. That's the first thing. So you can pay IMATIX or anyone else for support. You can offer us money and we will be on the phone 24/7. No problem. But the real answer isn't to have someone to support it. The real answer is this should never crash. This should work with 100% predictability. And there are actually ways to arrive at that. For example, you make things simpler. They will work more reliably. If you focus on simplicity rather than on functionality, things will become more reliable. If you remove pieces of your network, remove things in the middle, your network will become more reliable. And there's this big irony. People often talk about broker-based systems like it's a magic thing. And reliability, because you have a broker that can be reliable. And the truth is that the broker is the piece that breaks the most often. It's a very big point of failure. And with ZeroMQ, in many messaging patterns, not in all of them, but many, you can remove the broker. You can do pub/sub with no broker. You can do very, very high-speed pub/sub with a multicast switch and no broker. And that's going to work more reliably. You're going to have many fewer failure conditions than with a broker in the middle. You still will get things that break. You still will get things that break. And you have to test those breakages. You have to understand what reliability means in terms of actual failures, not just in a vague word like, you know, it may not crash. What's going to crash? My network, my server, my worker, my switch? Will someone trip over a cable and pull it out? What's actually going to happen? And all these things have happened. I've seen them all. I once killed a factory by moving the Unix server, and it just unplugged the cable from the wall. The power, like, oh dear. And no software can recover from that. And this kind of thing is what happens. So reliability is a whole series of threats and responses. And when you build a system for anything, it's not just for a nuclear factory, it can be for any kind of system, even a domestic control system or a mobile phone, you have to think of what are all my threats, what are all my failure points, can I reproduce them, and can I resolve them in a cheap and simple way? And if you do that properly, and if your software is built in a way where a solution will work the same way all the time, which is what you get from asynchronous messaging, it gives you that, a very predictable behavior pattern, then when there's a failure, the response will be very predictable. And then you know that you're safe. And that's the answer. There is no magic bit of paper that will make software more reliable. It's about the architecture of the software and the answers to a series of threats that you've defined and worked through and reproduced and tested the answers to. That's the best I know. And we've built systems that were very large and that we supported for, in some cases, for 15, 20 years. And it ran. And there's these basic patterns like asynchronous messaging is a very, very predictable behavior. We do multi-threading with no locks. It's all task-based, message-based multi-threading. It's very predictable, it's very reliable. We never get deadlocks, we never get conflicts, we never get, you know, strange wait states. It doesn't happen because of the design of the software. And so reliability is about removing reasons for breakage, right? Does that help?
Yeah, very much. At the same time, it's based on the community being attractive, being attracted and live. If someone wants to bite your market as MySQL did with Oracle, what then?
Well, like I said, our company is not a dominant force in the community. All we do is write the rules, and that work is more or less finished. So we're participants, but we're not owners of the product. We are part contributors, right? You can buy us. It changes nothing. If the problem is interesting, the community will continue to explore it and to resolve it. And if the process is accurate, then the way they work will continue to survive. I believe those two are true. I believe that the problem is interesting. As I said, the number of computers exploding will never stop. And I believe our processes for collaboration are the best in the world, and they can still be improved, but they're today the best we have. And so I believe that the problem is real, the community is active, and it will continue to survive. And whether I'm involved or not changes nothing. Changes nothing. It may change the speed at which things happen, which is not very important. For example, in the last 6 months, what I worked on was security layer, cryptography. So we had in ZeroMQ this problem that it was basically plain text. So using it across the internet isn't really fun. And I waited for a couple of years to see what people did in terms of answer. People have tried many solutions, mostly too complex and mostly at the wrong level. So eventually I got involved and I wrote a new protocol and designed security mechanisms and convinced a guy to implement them, which we did, and it was quite simple to implement, and organized a meetup where we tested it all and it all worked. So I'll get involved when there's really, I see really value. And I want to build products using that. I want that to work. But if I didn't do it, someone would do it eventually. Maybe a different way, maybe better than me, probably better than me. It would happen eventually. So in open source, you always have the choice. Either you wait, or you do it yourself, or you pay someone to do it. And we tell people this. You want something, send us money, send us a patch, or wait. And you can spend money, you can spend effort, or you can spend time. That's it. And that actually seems to work. It sounds like a really blasé, stupid answer, but it actually seems to work.
Do you think if you have a very specific problem, like the problems you face at CERN are quite specific, right? You don't have a lot of accelerators in the world. Do you think an open source project based on a specific problem can work?
So every big problem can always be broken into smaller problems. That's how you solve them. You never solve a big problem. If somebody was to come to CERN and say, I will write you your new SCADA, you would have to kick the guy. I mean, it's a really stupid thing to propose. Big problems, the first thing you do is break them into smaller problems and then solve each problem in the cheapest possible way. Okay? And essentially, your big problem at CERN is about connecting computers, and then the computers do a certain number of things, and they send certain information, but the solution to that is a layer of solutions. And at the lower layer, you have networking. Above that, you have messaging, which is what ZeroMQ does, routing and queuing. Above that, you have possibly access control and subscription and knowing what is where and addressing and location. And above that, you have user interfaces and APIs to Java and C++. And each of these problems you can take and you can solve. The whole thing may not be open source, but big layers of this can be open. And this is the same in any business, in any business at all, whether it's business of science or the business of chemicals or weapons or whatever it is people do in the world. Large sections of their stack can be open source. And where there's no benefit in making it closed, there's benefit in making it open. That's why open source exists. It's cheaper to have this stack, part of the stack, Linux, coming off from the community than making it yourself or than buying it. And so over time, the stack gets higher and higher and higher. With ZeroMQ, we're now at a certain level. We can expect this to raise over time and keep increasing. You'll see there's a product like Storm, which Twitter bought from a company called Backtype. They bought Backtype, 50 million. And Storm is a framework for distributed data processing, kind of like a parallel Hadoop, if you know that. And Storm is based on ZeroMQ. And Storm has hundreds of big users who don't know they're using ZeroMQ. Typical layering of solutions above the networking, right? And this will carry on over time.
Is any other pending question? Because at 12 there is apparently there is another meeting here.
Okay. One last question, and then we'll close. Thank you.
Can you compare ZeroMQ with the cluster communication protocol?
With a?
Cluster communication protocol, which is in Linux kernel.
You could use, and you can use ZeroMQ to build clusters. And in some respect, a ZeroMQ network is like a very, very big cluster, where every single computer becomes a server. And they're all talking to each other with certain patterns, with certain quality of service. You basically demolish the concepts of thin clients and fat servers. Everything is a smart server, and they're all interconnected. And you can use it to build all patterns of clusters, clusters where every peer has the same status. So possibly in a school, all the students have tablets, and they're all talking to each other. and they're all servers on this network, and there's no central server. Or possibly as in CERN, where you have clients and you have stuff there and you have devices there and they have slightly different properties. So clustering traditionally is a very specific pattern for fat servers talking together. I have these two servers in a cluster. But in more generally, it's just broad computing, distributed computing, which is what we do. Okay, we're going to close here. Thank you very much for coming. And please buy the book and take the PDF, it's free. It's also online. And thank you very much. Feel free to email me if you have any questions.
So thank you very much.
Thank you. Okay.